today we're going to talk about solving equations. The other day we solved equations that were just linear. Today they could be quadratic, they could be absolute value, they could be square roots. They're all ones that you've already seen before. Are you sure? I would hate to interrupt you. Okay. All right, so when we're solving today, there's lots of different ways to solve. A large portion of it is solving it graphically, which means if we're solving it graphically, that's where it crosses the x-axis, right? And we all remember how to use our graphing calculator to do that, I hope. So we're going to be talking about that as well today. I wanted to start right from the beginning. We're going to start off with example number 1. Let's say I have something along the line of x times 3x plus 11 equals 20. And I want to solve for x. First of all, we know we have to get rid of the parentheses in order to do so. So I'm going to go ahead and distribute. I get 3x squared. X times 11 is 11x equals 20. Now, I have a squared term in there now. And in order to solve this algebraically, I need to get the whole thing set equal to 0. So I'm going to move it over. So I have 3x squared plus 11x minus 20 equals 0. Now that it's in quadratic form, or we can either solve it by factoring, because it does have a middle term, so we can factor it, set the factors equal to 0. We can do the quadratic formula, right? We could complete the square, but in this one it's going to have a lot of fractions, so that's not a positive approach. So which way would you guys like to start by solving this one? Let's factor it. I like that idea. Yes, I agree. So we're going to start by drawing our x. Last number times the first is negative 60. Middle number is 11. The size of the x would be 15 and negative 4. But I'm not done. We have to put that in the box, right? First term of the quadratic is 3x squared. Last term of the quadratic is negative 20. The diagonal are the sides of our x, 15x and negative 4x. Out of the top line, we can take out a 3 and an x. Out of the bottom line, there's a negative right next to the side, so we're going to take a negative, and I can take out 4 out of both. Up and down, we can only take out an x, and here we can only take out a positive 5. Now before I take those factors and set them equal to 0, I want to just double check and make sure each one multiplies back where I want it to be, right? So now I'm going to take my first factor, which is 3x minus 4, set that equal to 0. And I'm going to take my second factor of x plus 5, set that equal to 0. In the first one, I'm going to add 4 to the other side. It's 3x equals 4. Divide both sides by 3, x equals 4/3. Right here, if I subtract 5 from both sides, I get x equals negative 5. How would I know that I have to have 2 answers from the very beginning? Thank you. The highest exponent is a 2. Very good. All right. So I want to show this, let's go with example number 2. Move to the next section. Let's say I have something along the line of this. Let's say I have 4 times, x plus 1 squared. And let's go with equals 18. So here are our options. Because that parenthesis is squared, I could multiply that all out. But that sounds like a lot of work. Do you think there's something algebraically we can do different so that we wouldn't have to do all that extra work? Okay, that is an option, but I said algebraically. Okay, but before I can square root it, what do I have to do with the 4 in front? Divide it, absolutely. So we're going to divide both sides by 4 until we get that squared term by itself. So here I have x plus 1 squared equals 9 halves. Do you want to leave it as 9 halves, or do you want to make it 4.5? Okay, whatever you guys want. All right, now, to get rid of the squared, what do I have to do to both sides? Square root both sides. On this side, I have x plus 1. On this side, correct. What else do I have in front of that, Orion? There you go. So one of the things I want to point out for those of you in the back that are talking, if I'm square rooting a variable, I have plus and minus 3 over the square root of 2. Plus and minus. Now, if I'm going to get x by itself, I can just subtract 1 to the other side. So I have x equals negative 1 plus and minus 3 over the square root of 2. Now, here's the wonderful thing about being an AP. You do not have to simplify that. You do not have to rationalize anymore. You can leave it just like this.
So why does the square thing only go on as 2? Well, if you're paying attention, you know.
This is this, hey guys, come on. This is the square root of 9 over the square root of 2, right? I square root both sides. The square root of 9 is 3. Okay. All right, so this, once you get your answer to a numerical answer, you don't have to simplify any further. So all you need is a numerical answer and AP is happy. Okay? Okay. So move to example number 3. So I know I haven't been telling you what problems, but it's pretty much following along. So right now I'm all the way up to 13 through 17. And we're going to go ahead and solve. This time let's solve by completing the square. Do you remember how to complete the square? Yeah, so let's talk about one of these. I'm actually going to do, let's do an easy one. How about if I have x squared minus 10x plus 2 equals 0. Obviously, you can't factor this. You can see that you can't factor it. There's no factors of 2 that are going to equal negative 10. And the leading coefficient is a 1, so I don't have to worry about undistributing or dividing it all. To complete the square, we first move this 2 to the other side. So I have x squared minus 10x. I had you guys, whoops, x. I had plus, and I had you put a blank, equals negative 2. Then to complete the square, you took half this middle number, so negative 10 divided by 2, and we squared it. Negative 10 divided by 2 is negative 5. Squared is 25. Whatever I add to this side, I have to also add to this side. Uh-huh. And the year before. Well, I guess Algebra 1 before. Okay. On this side, if I now have x squared minus 10x plus 25, I can write that as a perfect square. That is x. And if I were to, I'm going to draw my x so you can see it. 25, negative 10 on the bottom. What are my sides? Good. So that's what goes in my perfect square is x minus 5 squared equals, over here, negative 2 plus 25. is 23. Now we're back to where we were on the previous question. How do I get rid of the square root on both sides? Or square root both sides. So on this side I get x minus 5. On this side I get plus n minus the square root of 23. So what's the last thing I have to do to get x by itself? So I get x equals 5 plus n minus the square root of 23. Okay, and again, that's a numerical answer. You can stop right there. Yeah, it was towards the beginning when we were talking about a lot of the quadratic stuff. We got into harder things after that, but quadratic it was towards the beginning. Because we also used completing the square to move it into vertex form. But, all right. Let's do this. Example number 4. Solve using the quadratic formula. Do we remember the quadratic formula? Negative b plus or minus square root b squared. Good. There we go. All right, so we are going to use this to solve the next couple. So we are, in our homework, we're up to 19 through 23. So let's do one like this. How about 2x squared equals negative 3x plus 1. So in order to use the quadratic formula, we have to get the whole thing set equal to what, Logan? Thank you. So I have 2x squared plus 3x minus 1 equals 0. Again, this is my A, my B, and my C. So we have negative b plus n minus the square root of b squared minus 4. I put a little b above the 3. That's 3. Negative b, the b is 3. Okay, anyway, b squared minus 4 times a, which is 2, times c, which is negative 1. All over 2 times 2. Underneath the square root, we have 9, and then this is going to be plus 8. So we end up with 17 under there. So we have negative 3 plus and minus the square root of 17 all over 4. That's why I just wrote it down for you, so you have it in your notes, right? Can we keep going? Gentlemen, you sure? All right. All right, let's go to example number 5. All right, for example number 5, I want you to solve graphically. And let's say I have x to the third minus 4x plus 2 equals 0. If we're going to solve this graphically, we need to know where this crosses the x-axis. Maybe. All right, so let's go ahead, grab your graphing calculators. So what else does it do?
It returns twice.
It turns twice. Let's get this a little bit better, huh? How many times or how many solutions do we have here? We do have 3, right? Okay. Do you guys recall how to use your graphing calculator to find those 3? Yes. Mhm. Okay, go back. Because you have a negative instead of a minus 4. Okay? Nope, not that one. Oh, you want the minus. Subtract 4. Okay? You're good. Yes. Okay. Well, here. Go ahead and go to your window. Go into your window. Let's just change that to negative 10 and 10. Okay? Oh,
Wait, what?
just type negative 10. Negative 10. I guess let's clear it. Put negative 10. Down to the next one. Clear 10. No, positive 10. Okay, now go down to negative 10 and 10.
Right there?
Yep, negative 10. Positive 10.
Graph?
Yep, please. Isn't that better?
There we go.
Okay? So, we don't have any questions on how to find those, right? So, first of all, this graph ends up looking kind of like this. Okay, so you go into your second and trace. Go down to your 0. You have to hit left bound, right bound, and of course enter one more time, right? Then you have to move it over for the next one. Recall that? Then you go to the right bound. So then it should center around your point where you're crossing the line. Please. Do you recall now? Are you good? Come here. Okay.
I'm left, I just clicked
So
left one.
you want to go to the left of your first 0, which in the first one's going to be underneath it. Okay, so hit enter. See how that line's to the left of it now? Now you want to go above it. Yep. And then hit enter one more time. There you go. It takes you to that 0. That's your first answer. Okay? Well, for your first answer, yes. Okay? So you go back, second trace. Okay, down to your 0. Now you got to move it over here, so closer to the point. Okay, now go ahead. That's your left bound, so it's left to where this is, right? Hit enter. So now you got to go to the right. Oh, keep going. There you go. Not quite that far, because you get there. Okay.
You only have 2 answers, right?
No, you have 3. Yeah. Oh, it's because it's this way. It's zoomed out really far. I'm going to change your window real quick. See how it's at 1200? Yeah.
How do we go to the right bound?
Right. There you go.
Like once you get,
Okay.
I already did second trace and then I already did the left bound.
That's right. That's your right bound. It surrounds this point right here. So when you hit enter, you put enter. Yeah, okay, yep. So now you want to do the next one?
Yeah.
Okay, so second trace. Go down to your 0. Now you move it over here to the left of this one, which is going to be above it. Yep. Okay. Oh, above it. Above it. If you want this point right here, you've got to be above it because that's to the left of where it is. Okay, right there. Nope, not too far because it's got to be to this because you can't go past that 0. There, see, now it surrounds it. Okay.
Do you have a third answer? Or just
Yes, this one right here. So now you got to do it again. Okay, so is everybody clear now? There are 3 different places this crosses the x-axis. We have one here, we have one here, and we have one here. So you should have 3 answers. We are all clear? Okay. Now, as you're doing your work today, which I'm going to let you get started on here shortly, 39 and 41, which is the last couple, they are absolute value problems. Now, you can do them algebraically. Do we need to talk about how to solve absolute value equations algebraically? We do not, or we do? Okay. All right. Then I'm going to have you guys go ahead and get started.